Go!
Hello everyone, welcome to Practical GCP. Today I would like to talk about how to run batch jobs such as DBT jobs on the Google Cloud service called Batch. This is actually, I think it's a relatively new service, may have not got a lot of traction. At least I have not actually heard about many people using it. And today I would like to specifically focus on whether this is actually an Airflow Kubernetes pod operator drop-in replacement. I'll explain in a second why I have been thinking like this and why this is important, right? So if you consider this as an example, I'll explain where the problem is in a second. Consider you're running these things on a workload, whether that's DBT workload or any other batch workload that require custom packages to be installed on Python, or maybe other binaries that you need to install. It may also require high computation to run the workload you want to run, right? So typically you would do such things on a Kubernetes pod operator on Airflow cluster, which could typically be run on Google Cloud, for example, on Cloud Composer. So, but in those scenarios, one of the first things you typically would have to do is to run some kind of stuff on your local laptop. So Airflow has currently provided a Docker Compose setup, right, that you can actually run your majority of the Airflow workload on your laptop. But when it comes down to running workload on Kubernetes pod operator, it spin up the custom workload with your own kind of resources, with your own machine types, and to run your workload processes. And this is actually running inside, right? If you're actually running on a Composer cluster, all of this actually runs inside your GKE cluster as kind of a custom workload, but it's all kind of together. But when you run this locally, it's a bit of a nightmare to test because this thing is not supported out of the box. You have to typically set up tons of things, and it still doesn't behave exactly the same, because when it runs on the production environment or UAT environment, it would run on Kubernetes, right, inside Google Cloud, but it's not quite the same when you run it locally. So this creates a lot of problems to have exactly the expected workload as you run on your laptop to be reflected on your production environment, right? So, and this bit is where the main problem comes in. And now talk about Cloud Batch. So this is something, if you look at what it actually does in a nutshell, it's a managed batch service to schedule, queue, and execute batch jobs on a Google infrastructure. But in a nutshell, all it does is, you write a bunch of scripts and it actually provision the machines. It can be multiple machines in a compute engine group as well, right? So it's not necessarily limited to one machine. It can be used for high computation workload, and it actually manages the whole workload for you from the time of creating the job, monitoring the job. You can delete the job. You can do all sorts of things with it via the Google API, right? This is the very most important part. And now, if you consider this, so I've talked about earlier, when you submit the job on a Kubernetes pod operator, then it can be troublesome for your local testing, right? And to test the thing end to end. So, but instead, if you're thinking about using this approach, so typically you still have your Airflow, let's say in Docker Compose, on your laptop or running on Cloud Composer. So what you do is you actually simply, rather than running the pod operator, which involves quite a lot of process setting up, the queues, the IAM, all of that stuff you need to set up. But here, all you have to do is to create a simple Python operator to trigger the Cloud Batch API, right? So when you trigger the API, it would literally create, so all of this infrastructure is created on the managed batch service on the Google infrastructure outside of the Airflow or Cloud Composer scope, right? This has nothing to do with this, which means you can actually trigger the whole thing from your local environment or the Cloud Composer environment as identical workload, right? There's no difference between the two. And even better, you can package your Docker containers, you can do your own, local development completely away from Airflow right? Then just using this batch API service and testing everything end to end before you plugging it in. This, not only it can run the Docker workload, but it can also run just the script on a virtual machine if you prefer. But I think it will be much more powerful if you package everything in the Docker image and then submit it into GCR or artifact registry. Then you can actually run your workload, using the Docker image. So this is the kind of a design I've been trying out in the last couple of days. And even better, because of the Google API interaction with the batch service, you could also do things like this, such as using another Python operator, really lightweight one, to check the status, right? So rather than letting this one to wait for when this is going to finish, you can actually just submit it and go forward to check the status. If it fails, you retrieve the logs. There's actually log API as well. You can actually retrieve the logs and then print it in the Airflow cluster to display to yourself to see what is going on, and then you can fail the task or make it successful when this finishes. So this is pretty powerful. Now, let's have a look at in action. So what I want to show you first is, as usual, this repository and naming it GCP batch for DBT. The reason I want to talk about DBT job is I know quite a lot of you in the industry also run DBT jobs in using KubernetesPodOperator on a Composer cluster in Airflow, right? So I was trying to see, as a drop-in replacement, whether this is going to work. So just quickly run through the structure of this repository. So it's not hard to notice, I've got a DBT folder in there. So what this does is I've created a few things. The DBT batch demo is basically just a super simple DBT project that you can create this with DBT in it. And then the logs folder is just something it got automatically generated, which I kept it in here. But then you have the Docker file, which is something I've created, kind of copied from one of the previous version I've done before. It basically creates the DBT workload, the container with the users and everything kind of created and copied across, right? So then you can actually build it. And then profiles.yaml, last not the least, this is how you can run your workload of DBT using just OAuth. So you don't actually need to worry about any service count keys or anything. You just specify a number of parameters here where you want to run your stuff, and then this is actually got the BigQuery adapter. So I'll show you in a second what it looks like in BigQuery. Right, so in this one, I've put a few things in there. I have actually pre-packaged this in here. So you can see I've actually pre-packaged that and also tagged it with a version. So I'll show you what I'm going to submit this with the batch service in a second. Right, a few other things. The requirements.txt, all it needs is this batch service, the current version 0.4.1, and then the submit job.py is basically, it took me quite a bit of time to figure this out, but the way I've structured the scene, you might need to change a little bit to tidy up a bit, but what I've done is I've abstracted the whole thing. If you look at the very bottom, right, you can actually submit this batch service with a bunch of placeholders in here. So keep in mind, this is a fully managed service, right? There's no infrastructure or anything you need to create. The part of this configuration, you could do it with the JSON file with gcloud, but I think because I really prefer to run this, let's say in Airflow, or even you trigger it somewhere else, it's just so much easier using the Python client, the Python SDK. So now in here, you can put project ID, the region of the batch, and then the job where you actually want to run the job on the compute engine, the machine type, network and subnet, the service count email, which is important because if you don't use the default one, that's the default App Engine account, which has a lot of permissions. This one, you can restrict exactly what permission you want to give it to. And then the name of the job, which I appended a hash at the end. Then you give it the container image, the entry point, in this case is I want to run my DBT job. So there's a few things you want to tidy up here, but this is actually quite nice. If you just, take this code and then you can just change the container, and change the service account and change the command you want to run, and then you can basically use this, right? So it's pretty powerful. And like I said earlier, you can also use the getJob.py to actually, when you submit this job, you can see the status of this. So this is the second operator that you can use to track, where it got to with the job, and then you can decide whether you want to continue waiting or you want to fail it, right? Here, I've put quite a bit of details in here. This is the gcloud commands to allow you to create the service account and then attaching a bunch of permissions you need. So because this is a DBT job that is need to go and interact with BigQuery, so that's why it has data editor and job user. The object viewer is, because I'm using a Docker container here, it will need to have access to GCI in this case, which is stored in the object storage in cloud storage. And then with the agent reporter, so this is the thing that you need in order to run the batch service, right? So using this customized service account. When I was testing this out, it took me ages because I didn't actually read the instruction properly, like bits by bits. So I'll come back to this later, because the logging and debugging with the batch service isn't great. You're probably gonna scratch your head if you miss some of these really important ones in terms of debugging. And obviously you need to be able to write logs, right? Right. So let's have a look at this. So I've just managed to submit the job early on. So you can see this was done maybe just about 10 minutes ago, and it succeeded. So when you click on this, you see something like this, right? This is all you've got with the service. There's not a lot of information. So you can see I've run it on the Europe North 1 region. I'll explain at the very end why I'm not using the land region, and then there's actually quite a lot of limitations in there, but it doesn't really matter. And here you can specify the runnable. So you can see this is the container URL I've put in there, right? The batch entry point and the command I want to run with the DBT stuff. So finally is all of the things. You can run this parallelized workload. There's a lot more you can read on. I'll put some links at the end of the video so you can read on more. There's actually quite a lot of things you can do with this, including attach, storage or SSD drives, or run group workload and distributed workload, or lots of things in parallel. This is quite powerful. So this one is a quite simple one, because as you know, DBT does all of the workload in this case on BigQuery, right? So it doesn't actually need much resources. So I've only given it 1 core and half gig of RAM. Right. So the important part of this is the logging. So right, this is something you want to use a lot. So when you're actually clicking on it, what you typically get is this kind of thing, right? So you've got this is the ID of your job, and then you've got the log name of what kind of logs you want to see. This is actually not very useful, because there's actually a bunch of other logs attached to outside of this the batch task logs. So I typically just remove this, and then when I remove this, I'll see a lot more than that, right? So when I remove this, I see all of the you see this different kind of logs. So it'll contain all of these different options, and that's when you can see all of the different relevant logs, from creating the compute engine instances to fetching the GCI image and creating the image. You see this is pulling stuff. There's also report status with the help with the polling check, and then you can see here and it pulled the image, right? And then at the end it ran the DBT job, right? So here you can see it ran the DBT job and it's completed. So if I show you in BigQuery, you can see that the batch demo here, you've got the basic DBT model gets created, right? You've got a view and you've got a model. So this is kind of giving it the working end to end. One thing that's worth noting is typically you find with the KubernetesPodOperator with the K8 executor behind the scenes, it typically takes a while for the service to get started, and this is the same as well, right? But I found it actually quite quick, right? If you see, this is where it got started, which is 2108, right? And by the time it's actually finished, it was only 2 minutes later. So this is pretty quick. I mean, in terms of creating the machines and then getting everything ready to execute your job, is all within about 2 minutes-ish, right? So that is pretty powerful if you consider the amount of work it actually has to do using the batch service, right? So, but you can see this is like, you can run any kind of customized workload on this thing. So DBT is just one example of this, but this you can basically run whatever you like. It's just very similar to KubernetesPodOperator. So what you can consider, you can put whatever machine types in there. You can put more than one machine in there. You can even run some distributed workload, and that is actually quite powerful, right? So now the verdict. I would say it's very easy to deploy, and it's very easy to run batch jobs. And for me, it took me a couple of hours, but most of my time was actually stuck on some of the debugging stuff. But the actual service was quite easy to use. And then what I typically always do is, I put a kind of Python template to abstract all of these common variables that I can reuse in myself in the future as well, right? But now the local testing with Airflow, I haven't actually plugged into Airflow yet, but you can see there's no reason you can't, right? It's a private Google service. You can just use Airflow to connect to this thing without needing the internet. If you run it on Cloud Composer, you don't have to run it on Composer. You can run it on other things as well. You don't even need to use Airflow. But my point being, you can use this as a replacement of the operator, right? Right. And then the downside, I don't know exactly why, but the regions are very limited on where you can run the batch service. There's only a few of them, but it doesn't actually matter too much because that's all where the metadata gets stored. Whenever you run the service, like I showed you earlier, you should always specify where you want to run your compute engine instances, right? So that's where you say the workload is going to run, right? If you're going to attach any disks, that's where the disk is going to be. So although it has quite a few limited regions for where you can submit the job, but it doesn't really matter too much. Debugging can be quite a bit of pain for certain things. So what I do remember, one is, for example, when you submit a job, I made a mistake because I thought I've got the one core machine for the E2 instance, but obviously there isn't one, right? So when I submitted the job, it just says it's failed, right? And all it says is failed. There's absolutely nothing in the log. It just says it's failed. So I was scratching my head like, what was going on for like an hour? And then I realized I put the wrong machine type in there. There was another thing, and you can see there, is when I didn't read the instructions properly. I was kind of jumped the gun and tried to try something pretty quickly. And one of the things it was saying is with this the roles in here, so which is the agent reporter that you actually need to attach to the service count when you run it. So I didn't see that, and then I forgot that one. But what actually happened was the service actually got stuck. So rather than saying, oh, sorry, you've got permission 403, whatever, right? It didn't say that. The logs basically just saying it created the machine, it submitted the instance request, and it was stuck, right? I can see the compute engine instance was created and it was just stuck in there for a very long period of time. You can see in here, this job stuck at 39 past. And what I did was, because I didn't know which permission I was missing at the time, I've given it editor permission, right? Not supposed to, but after I given editor permission, that's when it started failing and saying permission denied. But that was like almost like 15 minutes ago, almost 15 minutes later, right? That was almost 15 minutes later. But I've had a few other jobs I basically left it in there for like more than 40 minutes. It just wasn't doing anything. It was just stuck. And I think there was a timeout maybe around 30 to 40 minutes, and then it just failed, and it doesn't tell you why either, right? I think this really something can be improved if some of these things has not been specified properly. But having said that, if you do specify it properly, don't be like me, forgot to read the documentation, which is the quick start in there, talking about what roles you need to attach to the service count to use it properly. And then, to be honest, the debugging was my only problem. And then after I removed some of these mistakes I made, I've not actually had any other issues, to be honest. It was mostly pretty easy to use without any other issues. It's just that, a few things I didn't read the instruction when the role was missing, when the permission was a problem. But if you actually have a permission problem after for your container itself, when you're trying to talk to BigQuery, for example, and then that was all shown in the logs. That was quite obvious. It's just when you miss that agent, right, the batch agent, the report agent permission, it just got stuck, right? This you literally could not see anything in the logs for that. And so, but lastly, I just want to say, I think, in my opinion, this is a perfect drop-in replacement of Kubernetes pod operator. You do not have to deal with all of that, faffing around on local development testing. I know some of you are very smart guys who can actually develop everything yourself locally from end to end, but how many people can actually do that and it works well for a very large team? What if you can just use something else instead that doesn't require you to do anything at all, right? That's always be my preference. So thank you very much. I think this is something that made my day today. I will actually really like this thing, and I think read a bit more. This is a lot more this thing can do. But I would say my preference is to use something for, similarly to what the Kubernetes pod operator does for, single node, kind of whatever size of the node for highly compute or DBT jobs. These kind of things I would use it for. But I may not want to use it for distributed workload where, other things can be optioned with Dataprog, but Apache Beam with Dataflow. I think those tools are probably a lot easier, but it really depends on what the libraries you use, what framework you use. But it's always good to have more options, right? Okay, thank you very much. And that's the end of the video, and I'll see you next time. Bye-bye.
Go out!